Welcome to lesson 2-4, average rate of change. Let's start by looking at what average rate of change actually is. Average rate of change is the slope of the secant line between 2 points on a function. So what that means for us is that if I have this blue function here, and I wanted to find the average rate of change from here, x equals 2, to x equals 4, what I would do is actually use the slope formula for the point 2, 1, and 4, 2. And it is the traditional slope formula, rise over run, and you are allowed to put the points in any order you want. So any point could be x2, y2, and any point could be x1, y1, as long as this 2 is underneath this 1, and this 4 is underneath this 2. So we did 2 over 4 minus 1 over 2. And you get a slope of 1/2 here. So that is the average rate of change of this function between 1 and 2. So it's essentially the slope of the line that connects those 2 points on a curve. So let's take a look at some examples. In example 1, it says for the graph of the function f of x equals x minus 3 squared, whose graph is shown, find the average rate of change between the following points. So I have x equals 1 and x equals 3. So the first thing I'm going to do is put 1 in and get a y value out. So I have the point 1, 4, and I'll put 3 in and get a y value out. So that's 3, 0. And then I'll put those into the slope formula to get my average rate of change. So in my slope formula, I did 4 minus 0 over 1 minus 3, which is 4 over negative 2, or negative 2. And that makes sense when you're looking at the line that connects this point to that point, because it is obviously a negative slope and it's gone down 4 and over 2. So what you're going to do is you're going to try part B all on your own, and you're going to put it in your notes for this, which you are going to turn in sometime today, attached to the video assignment. So go ahead and do that. I will check that answer for you, and then go on and hit play for the next example. In example 2, it says, if an object is dropped from a high cliff or a tall building, then the distance it has fallen after t seconds is given by the function d of t equals 16t squared. Find the average speed, also known as the average rate of change, over the following intervals. So it says between 1 second and 5 seconds, and between t equals a and t equals a plus h. So let's look at this first interval. What we need to do is take the 1 and evaluate for 1 up here, which gets you 16. And we take the 5 and evaluate for 5 up here, which gets you 16 times 25. And that's going to get us our ordered pairs that we're putting into the slope formula. Then we'll just calculate with the slope formula. So it'll look like this. So d of 1 is 16, so that gets me the point 1, 16. And d of 5 is 400, so that gets me the point 5, 400. I just put it into my formula, and I ended up with getting approximately, well, exactly 96 feet per second. And it's feet per second because it said we were given time in seconds, and it gave us the units of the distance in feet. So now for part B, it's going to be the same process, but this time we're working on something that has variables. So instead of having a 1, we're going to have an a. Instead of having 5, we're going to have an a plus h. So pause the video, try and do that, and then hit play to see my answer. Okay, so for d of a, I got 16a squared. For d of a plus h, I had to square a plus h, and then I had to multiply by 16. So when you square this, you get a squared plus 2ah plus h squared, and then times 16 gets you this thing. Now, when I put it into the slope formula, I always do the a plus h in the first position. So this comes here for the y value, and it's over a plus h, and then it's minus the 16a squared minus a. So when you simplify this, the 16a squareds cancel out, and the a's cancel out. So you're just left with 32a h plus 16h squared all over h, and that reduces to this. Now, if you want to, you can factor out the 16. It doesn't matter. You can either leave it 32a plus 16h, or you can factor out the 16. Doesn't matter. So let's take a look at a related topic to this. It's called the difference quotient. The difference quotient is used to calculate an instantaneous rate of change when we're doing calculus. But for now, we're just going to do a rate of change using x plus h and f of x. Now, notice that this looks just like that last question we did, because technically we did use the difference quotient just with different variables. So essentially, nothing has changed. We're still using the slope formula. We're still figuring out how fast something is changing. So it's still average rate of change. Let's take a look at an example for this, though. Okay, in example 3, it says the table gives the outdoor temperatures observed by a science student on a spring day. Find the average rate of change between the following times. So in part A, we're given 8 a.m. and 9 p.m. And in part B, we're given 1 p.m. and 7 p.m. So what we're going to do is use the ordered pairs from our table. So we have 8 a.m. and 38 and 9 a.m. and 40. So what we're going to do is put these into the slope formula. And we'll just do 40 over 9 minus 38 over 8. And again, the order doesn't matter. I usually use an order that's going to get me the fewest negative numbers. So it looks like this for our. So I end up with 2 when I do my subtraction, and I can say that the outdoor temperature increases by 2 degrees per hour. Now, one thing to be aware of is that when you're dealing with time, if I had a time span that takes something in the morning all the way through to something in the afternoon, you just want to be careful, because I can't just do 10 minus 3. That's not going to work because of how time works. So just be careful about that. It doesn't happen in either of these examples, but it's something to keep in mind when you're dealing with time. So in part B, it says to do 1 p.m. and 7 p.m. So what you're going to do is you're going to pause this video, do it in your notes that you're going to turn in, and I will check it there, and then press play to see example 4. In example 4, it says let f of x equals 3x minus 5. Find the average rate of change of f between the following points. And they give you A is x is 0 and x is 1. In part B, x is 3 and x is 7. And in part C, x is a and x is a plus h. So what you're going to do is you're going to calculate all 3 of these. So press pause, calculate all 3, then hit play to check your answers. Then I have a thought question for you that you're going to answer in your notes. So for part A, I got a value of 3 when I put it into the slope formula. Part B, I got a value of 3. And in part C, I got a value of 3. So my question for you that you're going to write about in your notes is why the average rate of change is 3 in all 3 cases. What are your thoughts? Why is it? Why did it come out to the same value every single time? So that's it for this video. Let me know if you have any questions, and don't forget to do your homework.